we will now look at a spin lock on power. Recall, a spin lock is a lock which does not involve the operating system. So it busy waits until the CPU gets the lock. And also recall that mutex in pthreads on Linux uses spin lock in the case when there is not much contention on a lock, and otherwise when the busy waiting would be too time consuming, I mean too long period of time of waiting, the operating system is involved and will schedule another thread or process. Okay, so if we use spin lock not as part of a pthread mutex, then we should clearly use them only for very short critical sections. But if we use pthreads, then it will adjust properly, so we don't have to think about if it's a small or long time-consuming critical section. Okay, we can do this using portable C or C++ code in standard C if we wish to avoid the relying on an efficient mutex implementation. Okay, so but let's look at this. And first of all, this is not only for power, but similar code is for other CPUs which use the load locked and store conditional. So as I mentioned previously, it's called load locked or load linked or load and reserve. And this is instead of the test and set atomic instruction. So the lock variable, which is just an int or similar to an int, and we can see that because we load a word, the W means loading 4 bytes, and the address of this is in R3, and we load to R6, and then we compare the bytes of this R6 with the bit pattern saying that the lock is available or unlocked. And if it's not, branch not equal, then we repeat to the loop and just continue busy waiting. Eventually, the owner of this lock will write the bit pattern to it that it's unlocked, and then we will get the cache miss after a while and load the data again. Okay, so this branch not equal will not branch back, but continue to the next instruction. And then we try to store the bit pattern saying that this is locked. And if there was no store by another thread between our load and store conditional, I mean load and reserve and store conditional, then this store conditional succeeds. If it does not succeed, it will set a bit in some status field of a register, and the branch will loop back to the beginning and restart all over. If we succeeded, then we do an async and then load the first, perform the first load of the shared data after this taking of the spin lock. When we unlock, the first, it's not first, but the last thing we do before unlocking is probably store to some shared data, and then we do this lightweight sync, and after that we write the bit pattern to tell the others that this spin lock is now unlocked. So this is the same bit pattern there in R4 as there. And it happens to be the same address, which is not necessarily the case. I mean, for this lock, it's in R3. It's probably a good idea by the compiler, but not necessarily, of course.